If I told you the key to mastering the algorithm lies in understanding just 7 simple tips. So without any delay, let's dive into the 7 tips. The first is data structure is the key. How many times do you code without using any data structure? Like no variable at any stage. Maybe for a very tiny program, but in real world, you have to use data structure. Even for a simple algorithm like this, check if a given number is even or odd. Data structure is a way to organize and store data in such a way so it can be retrieved and modified efficiently. Data structure defines the physical form of the data. An algorithm is a step-by-step procedure or a formula to solve a problem. The algorithm operates on the data, so you need to know at least basic data structure to start with the algorithm. Without data structure is trying to build a house without knowing the material which you can use to build a house. So once you have basic understanding of data structures, it's time to understand what exactly an algorithm is. And this is my second point. Not every logic is an algorithm. Learn the difference between regular coding and a true algorithm. There are 5 characteristics of a true algorithm. The first is clear inputs. An algorithm has a clear inputs. You must be crystal clear what you are expecting in. And the second is clear output. Similarly, the output of an algorithm should be clearly defined. Third is specific steps. Every step in an algorithm must be precise, straightforward, and to the point. For example, if you're adding 2 numbers, the steps are clear. You will take first number, then second, then you will add. Simple, right? And the next step is finite steps. An algorithm should have a limited number of steps. And finally, uniqueness. Each step in an algorithm is unique and important. Usually the output of one step becomes the input of next step. Once you know data structure and key characteristics of an algorithm, it's time to measure the efficiency of an algorithm. And this is my next point, understanding big O notation. In really simple words, big O notation is like a speedometer of your code. It helps you to understand how fast your code runs and how its performance change if the data change. Big O notation tells you about the worst case scenarios in terms of time or space, like memory, your algorithm needs. Let me share 2 most common big O notations. In big O notation, the term is read as O of 1 or simply order of 1. This notation represents constant time complexity. It means the time it takes to run the algorithm is the same regardless of the size of your data. And the second is linear time. Again, the term is read as O of n or order of n. This notation indicates linear time complexity. In this case, the time it takes to run the algorithm increases linearly with the size of input data. As the input size grows, the time will grow accordingly. Hope you get an idea. Whenever you try to solve a big problem, try to break it down into smaller one. And this is my next point, divide and conquer. Let me share a very basic implementation of binary search using C# code, just to give you an idea about divide and conquer approach. In this code, the binary search function takes a sorted array and a target value. It then constantly divides the search interval in half. If the value of the search key is less than the item in the middle of the interval, narrow the interval to the lower half. Otherwise, narrow it to the upper half. The process continues until the target value is found or the interval is empty. This is a classic divide and conquer approach where a large problem is simplified by dividing it into smaller and more manageable problems. Divide and conquer is a powerful technique. It divides a bigger problem into smaller ones. You can apply this strategy to a wide range of problems and you can enhance the efficiency and effectiveness. And the next point is dynamic programming. Dynamic programming or DP is a method in computer science to solve complex problems by breaking them down into simpler subproblems. There are 2 primary approaches to implement DP. Top-down. This approach involves writing the algorithm recursively in a natural manner. And the second is bottom-up. DP table by iteratively solving each subproblem. Dynamic programming is a smart way to solve complex problems by simplifying them and avoiding unnecessary work. And the next point is recursion. Mastering recursion is essential for all the developers. Recursion is a method of solving problems where a function calls itself as a subroutine. This technique can simplify the code and improve the readability. A classic example is find a factorial of a number. The factorial of a number n is the product of all positive integers less than or equal to number n. Let me share a quick example how you can implement recursion using C#. In this example, the factorial function calls itself with n-1 until it reaches the base class where n is either 0 or 1. When the base class is reached, the function returns 1 and then it starts resolving all the pending recursive calls by multiplying the numbers. For example, if we have to calculate a factorial of 5, it will be 120. And my last point, but most important, is practice. Practice makes a math perfect. Reading theory is good, but without practice, theory is of no use. Consistent practice is not only enhance your problem solving abilities, but also helps in retaining the concept you have learned. Practice is really crucial because it helps you to boost your skills. When you practice regularly, you become pro in your field. And remember, algorithms are not crucial for the interviews, but also they are crucial for the backend development. Ready to learn 7 skills which you need for backend development? 7 key skills that helps you in backend development in 2024. And thanks for watching.